Assalamu alaikum. My name is Dusmuhammad Khalid, and today, inshallah, we will do some practical practice of the previous topic, which was about prime factorization. So, in the previous lecture, we discussed the concept of prime factors. We individually discussed what is prime and what is factors. We deeply understood about these two terms, and then combinedly we discussed the prime factors. In today's lecture, I am going to perform some practical or practice questions over this topic which are given in the book. So let's be with me. So the first question given in the book is write all these factors, write all the factors of these numbers. It means that the given numbers which are 8, 15, 57, 54, we are just asked to find the factors of these numbers. So what are the factors? Actually, I have already told you that the number which completely divides the given number will be called its factor. So we had discussed two methods as well. One was the branch and the second was the division methods. So I'm going to perform the first question, which is 8. So I'm asked to find the factors, not prime factors. I'm just asked to find the factors of 8. So I will perform through branch method. So what I have to do, I have to divide it into the easy factors or easy multiples. So 2 4s are 8. 2 4s are 8. So 2 is the factor of 8 and 4 is the factor of 8. Now, the second number which is given is 15. So I will find the factors of 15 as well. So by performing branch method, let's write 3, 5, the 15. So if I try to divide it more, I will not be able to divide it more because 3 cannot be further split it into multiple numbers or cannot be written in the multiplication of two different numbers. So all the factors of 15 are 3, factor of 15 are 3 and 5. So these are the factors of 15. Now the next one number is 57. So I will write it just 57. Now if you think over it, if you find, you will get that 57 is the multiplication of two numbers which are 19 and 3. Now if you search over it, you cannot further divide the 19, the number 19. It's a prime number as well, but I'm not going to that discussion the prime numbers. We will go through in the coming questions which are listed on the board. So the factors of 57 are 19, 3, and obviously 57 is also the factor of it because 57 is divisible by 57, or in other words, if I say 57 is divisible by its own, and you can write the 1 as well because 1 is always the factor of every number. Now the next number is 54. I will perform the factorization of this number through division method so that you get familiar with that method as well. So I will just have to write the 54 here inside, and now I'm gonna to find us the smallest number or smallest prime numbers or everything else. So if I look here, if I examine these questions, so it is divisible by 2. Why it is divisible by 2? Because the last digit of this number is even, and whenever the last digit of a number is even, it will always be divisible by 2. You can check it as well. So 2 2s are 4 and 1 comes with 1's 14, 2 7s are 14. Okay, great. Now 27 is not divisible by 2. Got it? So if I look over it, it can be divided by 3. So I will check the 3. So 3 9s are 27. Now if I examine it again, it can again be divided by 3. So 3 3s are 9. And again 3 1s are 3. So factors of 54 are 2 and 3. As the 3 is repeated multiple times, so it is enough to write just once. Now let's jump to the other question, which is write the first 10 prime numbers. We are asked to write the first 10 prime numbers. So first of all, we will write the first 10 numbers, which are from 0 to 9. Form the division or a branch tree method for each of these numbers, you will find that 2 is prime because it's just divisible by itself and 1, nothing more. 3 is also prime. 4 is not prime because 4 is divisible by 2, by 4, by 1. So it is not prime. I will just mark across here. 5 is also prime. And why it is prime? It's your task to think over it. 6 is not prime. 7 is prime. 8 is not prime. And 9 is also not prime. It is odd. The factors of this are 3, 9 and 1. So there are multiple factors of this digit, so it is not prime. So out of these numbers, which numbers are prime? Out of first 10 numbers, which numbers are prime? So these are 2, 3, 5, 7. Now maybe a question arises in your mind that why not 1? 1 is not prime. It is excluded. We will have to count the numbers from the 2. No, let's count these number 1, 2, 3, 4. But we are asked to write first 10 prime numbers. So after 7, 8 comes which is not prime. 9 comes which is not prime. 10 comes which is not prime. 11 comes which is prime. So I will write 11 here as well. So total numbers are 5. Now 12 not prime. 13 it's prime. Similarly 14 not prime. 15 not prime. 16 not prime. 17 yeah it's prime. 18 not prime. 19 yeah it's prime. 20 not prime. 21 not prime. 22 not prime. 23 yeah it's prime. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and just write one more with it from your mind. So these are the first 10 prime numbers. Now the third one question is express these numbers as the product of its prime number. We are given the numbers, for example 48, and our task is to express this number as the product of its prime factors. So first of all we will have to find its prime factors and then we will show it that this number is the product of its prime number is equal to a product of its prime number. So by division method I will divide with 2. So 2 2s are 4, 2 4s are 8 again with 2, 2 1s are 2, 2 2s are 4 again with 2, 2 1s are 2, no, sorry 2 6 are 12 again with 2, 2 3s are 6 with 3, 3 1s are 3. So 1 comes, so our process terminates. Now we have to write it like this: 48 is equal to 2 multiply 2 multiply 2 multiply 2 multiply 3. So isn't it equal to 2 to the power 4 multiply with 3? So if I write it like this, it will be okay and it's the actual answer. Similarly, we are asked to write these numbers as the product of its prime factors. But in this case, the given numbers are complete square. If you see carefully, the given numbers are of complete square. So you can find the answer or the prime factors for these numbers just like the above numbers. So we have 36. So isn't it equal to 6? 6 is 36. Now 2 3 2 3s are, and similarly 2 3 2 3s are. So can I write it like this: 2 to a power 2 multiply with 3 to a power 2 and it will be equal to 36. You can calculate it. So it's the easy way, I think. Similarly 25. So if I write 25, so 25 is equal to 5 into 5 square 25.